Okay, we're going to solve radical inequalities, and there are some ideas that we need to believe before we can get started on these. And the first is that the radicand has to be positive. So we're going to deal with that first. The radicand is this highlighted stuff in pink, and we are going to say that this has to be positive, which means that it has to be greater than or equal to 0. And that's because, well, let's say I put in 2 for x. Well, if I put 2 minus 1 in for x, then I'm going to get that this is going to be a positive 1, and that falls in the real. But what if I made this a negative 2? Well, if it's negative 2, then I'm going to get a negative 3 under the radical, and that's going to be the same as having radical 3i, and that's imaginary, and I can't have imaginary answers. It needs to be in the set of real numbers. So I'm going to do the math that says for what x values will I always be positive under the radical. So what I'm going to do is I'm going to do this math problem right here, and I'm going to say, well, I'm going to have two sides of my inequality, and I'm going to isolate my x. I could add 1 to both sides, but we'll do that. And that's going to give me that x is greater than or equal to 1. So the minimum value, the smallest number that my radicand can have for that x is going to be 1. So I'm going to say, well, I need to know that that's a thing, that my x has to be greater than or equal to 1, or that 1 is the minimum value for x, right? So I can say this in both ways. And I'm going to keep this on the side over here because I need to know this. I'm going to have to come back to this, that's a thing. I have a minimum value that I can have in my inequality because I can't have anything that's less than 1 and still have my radical be in the reals. Okay, the second thing that I need to know is that the square root and the power of 2 are opposite operations. So I'm going to write this over here and say, well, I know that the square root of something and the power of 2, well, those undo each other. Those are opposite operations. So I have that in the back of my mind. That's one of the things I need to know when I'm solving this. And the third thing I need to know is that I have to isolate the radical before I do any of the solving of the inequality. So I'm going to rewrite this radical down, this problem, and say I've got 3 radical x minus 1 is less than or equal to 12. And I'm going to say that this part right here, well, this is the whole radical. And I have to isolate that first. So I'm going to treat it as if it's an a. So let's say, what if I had something like this? I had 3a is less than or equal to 12. So I'm treating that radical as if it's just a variable. And I would divide by 3, and I divide by 3, and that's how I would get that alone. I would isolate it. So I'm going to erase that part. I'm going to treat it just like it's a variable and go, I'm going to divide by 3 on both sides, and that's going to isolate my variable. So that's this step right here, isolating my variable or my radical first. So I'm going to write this down as radical x minus 1 is less than or equal to 4. So now I'm back up here to this idea that my inverse operations are the square root and the power of 2. So I know the index here is 2, so I can undo that by doing a power of 2, and what I do to one side I must do to the other. And that means that these will cancel out, and that's going to give me my x minus 1 less than or equal to 4 squared, which is 4 times 4, or x minus 1 is less than or equal to 16. Well, now I'm down to solving an equation, and I can put my line in and say this is my two sides of my equation, and I'm got this goal of getting my x alone, right? I want this to be alone on the left side of my inequality. And so what I'm going to do is I'm going to add 1 to both sides, or I could circle and move it. This would be x is less than or equal to 17. Okay, Well, that's part of my answer. But remember that back here, we had this whole thing where we said we had a minimum value, and that our minimum value was that x had to be bigger than 1. So I'm going to say, well, I'm going to bring this inequality down, right down to here with this equation and say I know that my x was greater than or equal to 1, which is this part right here. And that ends up being the answer in its entirety of my inequality.